You're going to need two things for today's video. You're going to need your endangered species sheet from this morning, and you're also going to need a graphing calculator. Now, for those of you that are struggling writing an equation of exponential growth or decay, your calculator will actually do it for you, and that's what I wanted to show you today. Now, I've picked my own endangered species here. We've got a snow leopard. Population has been decreasing exponentially. So, to write the equation that would fit this data in the t-chart, my starting amount is 6,000. My time is going to be my x values, my exponent. And then I need to figure out my base or my rate of decay. Now, in order to do that, I can just take any two consecutive values in my chart here and divide them out. So if I were to take 5,700 and divide it by 6,000, that should give me my rate of decay, which is 0.95. Or in other words, the population is 95% of what it was the year before. Or I am losing 5% of my population. But as I mentioned, your graphing calculator will write us that same exact equation. So on your calculator, you're going to go and hit Stat, Edit, and now you get into your lists. Now, I have some numbers in one of my lists that I don't need there, so I'm going to go up to the top of my list, up to highlight L1 and hit Clear, Enter, and that will get rid of all my numbers there. And now what I'm going to do is I'm going to type in my t-chart of my snow leopards into my calculator. So my L1 is going to be my years. 0, enter, 1, enter, 2, enter, 3, enter. So you can do that on your calculator. And then in L2, we're going to put in the number of species. I'm going to do my snow leopard. You do your animal from this morning. Once you have your XY t-chart copied into your calculator, now you're going to hit Stat again. And we're going to slide over to Calc because we want the calculator to calculate an equation for us. Now, underneath this heading, we have a whole multitude of options to choose from. But we know that our animals are either growing exponentially or decaying exponentially. So we want to look for something in this list that says exponential regression, or expreg. On my calculator, it is number 0. So exponential regression will write the exponential growth or decay equation for us. So hit Enter on 0. Some of you, your screen will look like mine. So in this case, we're going to go and tell it what lists we want it to do the exponential regression on. So we need it L1, so I'm going to go second, number 1. Comma, which is up above the 7, second 2 will give me L2. And then hit Enter. And abracadabra, right underneath, y equals a times b to the x, which is our standard form of an exponential equation. It tells me my a, my starting value is 6,000, and it tells me my b, my rate, is 0.95. And some of your calculator screens look more like this. The title, Exponential Regression, is at the top. And then XList was our years, or our L1, so you need to do second number 1 to get L1 to show up there. YList, our number of endangered species, were in L2, so we're going to go second number 2. Then you can skip over frequency lists, leave it blank, store regression equation, leave it blank, and just hit calculate, and it should give you the equation that models your t-chart. So let's have you do a little practice on your calculator. Let's say the apartment that you're living in, the apartment complex, charges $1,100 for rent right now. But their plan is to raise the price 10% every year, which would give us this t-chart. So copy this t-chart into your calculator's lists. And once you have those values in there, use your your exponential regression under stat calc and get the equation that's going to model that rent growth. So our equation is 1100 times 1.1 to the x power. And that should make sense because our starting amount was 1100. I said our rate of growth, it was going to grow 10% each year, so that'd be 100% plus an extra 10%, which is 110% to the x power. And one last check, if you were to do 1464.10 divided by 1331, it will give you 1.1 as our rate of growth.